All right, so here's a list of all of our rules. And let's start with the negative exponent rule. So we just talked about this one and basically confirmed it. But we also have a set of other exponent rules. So anything to the negative first power is just 1 over itself, right? Basically 1 over itself to the first power, but anything to the first power is itself. Okay. Also, if you start out with a negative exponent on the bottom, then it goes to the top. So I always say if you have a negative exponent, either drop it like it's hot or flip it to the top. That's how I remember it. So a negative exponent basically changes position of its base, right? And when you change the position of its base, then the exponent becomes positive, right? And notice how the base stays the same, just the exponent changes, okay? All right, and so you can also, if you have a to the negative n power, you can write that as 1 over a to the n. So using the power rule to some extent, or at least, almost the reverse of the power rule. And then if you have a fraction, the quantity of a fraction to a negative exponent, then you can flip the fraction and change the sign of the exponent, right? So basically a negative exponent flips a fraction over or changes the position of the base. All right. Going through other rules, we know anything to 0 power is 1. We know that when we multiply like bases, we add the exponents, right? We know that when you divide like bases, you subtract the exponents. When you have a power raised to another power, you multiply the exponents. When you have a power of a product, you can distribute the outside exponent and multiply it by the inside exponents. And the same thing with the power of a quotient, right? You can distribute the outside exponent to the inside exponents. All right, so in this lesson, we'll be using all of those properties, and now with negative exponents, right? So let's try some examples. All right, so number 2, I have 3 to the negative third power. So I can evaluate that, right? First of all, I know when I have a negative exponent, I'm going to drop it. I'll drop the base, right? So it becomes 1 over 3 to the third power. And then 3 to the third power, we can evaluate either in our head, on our calculator, on paper. So 3 cubed is 27. So that's our final answer. All right, number 4. So I have negative 3 to the negative fourth. I'm going to start the same way, negative exponent. I'm going to drop it. So becomes 1 over negative 3 to the positive fourth. Notice I'm keeping the parentheses, right? This exponent affects everything it's directly touching, so it affects the whole value inside the parentheses. And then when I evaluate negative 3 to the fourth, that would be negative 3 multiplied by negative 3 by negative 3 by negative 3. And so that would be positive 81. And just remember, when you have a positive exponent, or excuse me, an even exponent to a raised, or a negative base raised to an even exponent, that's how I should say it, you'll end up with a positive value, right? So number 8, here we don't have parentheses, right? So that this negative 3 only affects the 5, not the negative. So when I drop it, it's actually going to stay negative on the outside, and just the 5 is going to be raised to the positive third power after you drop it. So I'm just dropping the 5, not the negative, right? And so this will be negative 1 over 5 cubed, which is 125. All right, so watch out. Be careful whenever you're dealing with exponents that you make sure you're aware of when to include the parentheses and when not to include the parentheses, right? Because it does make a difference. All right, number 10. So here I have a negative exponent on top and a negative exponent on the bottom. So I'm actually going to flip them. So it'll end up with 6 squared on top. Okay, so I bring that to the top. And then 3 to the negative fourth. I'm going to drop that. And it'll become 3 to the positive fourth. And now we can evaluate. So remember, these aren't like bases. So we can't just combine them. We can't divide yet because we have to do exponents first. And we can't use our quotient rule because these are not like bases, right? So I can't just subtract the exponents. So I'm just going to square the 6. That gives me 36. And then 3 to the fourth is 81. And so now I can divide by a common factor, which in this case would be 9, right? So 36 divided by 9 would be 4. 81 divided by 9 would be 9. So 4/9 is our final result.